In this lesson, we're going to talk about congruence. Congruent just means figures that have the same shape and size are said to be congruent. If I give you two triangles that are essentially the same, we're going to say these two things are congruent. And that's a symbol for congruence. It's like an equal sign with a little tilde on top of it. So let's know they're congruent. Congruent transformations, that's any transformation that preserves the shape. We talk about reflection, reflect the triangle, it's the same triangle still. Translation, if you move it, same picture. Or rotation, if we rotate it. These are also known as isometries. Those are all congruent transformations. If you do them, you don't change the shape at all. They're still going to be congruent. A congruency statement just lets you know the order in which things are congruent. If I say AB is congruent to CD, that lets me know that, hey, A is congruent to C, and that B matches up with D. So that's a congruency statement. The order matters is the general idea there. Let's use that to talk about congruent triangles. So here's two congruent triangles, and we have our congruency statement right there. And remember, order matters. So this right here tells me everything I need to know. Angle A is going to be congruent to angle D, like it says right here. Notice how they both have one curve. Lets you know that they match. Angle B is congruent to angle E, just like it says. And they both have 2 marks, let you know that they go together. And then angle C goes with angle F, all for the congruency statement. So it works the same thing with sides. If we look at here, side AB should go with side DE, like it does. AB, 1 mark, goes with side DE, 1 mark. Likewise, you can do the last two, BC, EF. BC goes with EF, BC goes with EF. And remember, the marks let you know how they correlate. Here, AC is going to go with DF because they both have 3 marks. AC, first and last, goes with DF, first and last. That's how you could read a congruency statement for triangles. And keep in mind, corresponding parts of congruent figures are congruent. If you have 2 triangles that are congruent, then all the corresponding parts, like AC, all the things we talked about, they're going to be congruent. Okay, let's do an example. I'll give you these 2 pictures here. I'm telling you triangle JKL is congruent to triangle MLP. We want to name all the corresponding angles. Now, if we just look at the pictures, they are reflected. Angle J goes with angle M. So J goes with M. So angle J is congruent to angle M. Notice I wrote an angle symbol and I wrote a congruent symbol. Next, K goes with N. K up here goes with N right there. Angle K is congruent to angle N. L has to go with P. Angle L is congruent to angle P. Corresponding sides work much the same way. If I look here, it might be a little hard because these are reflected, figure out which ones, but see how JK, how it's between the one symbol and the double symbol? It has to match with the same thing here, between the one angle and the double angle symbol. So JK is congruent to MN. And let's see if I wrote that correctly. JK is the first 2, MN, first 2 matches properly. The single angle mark matches the single angle mark, and the double angle mark matches the double angle mark. Okay, next one, I'm just going to use a congruency statement here. KL goes with NP. So KL is congruent to NP. KL is over here, and NP is right here. And then lastly, we have JL is congruent to PM. Actually, MP. Order does matter. If I do JL first and last, has to be first and last MP. These match. And that's how you use a congruency statement. Here's the same thing, but using a polygon, quadrilateral to be exact. Now, this is still the key. The congruency statement is still the key. If I want AB, let's go angles first. Angle A is going to go with angle E. You can see from the marking, angle A has one mark, and angle E has 1 mark. And the same goes with the rest. Angle B goes with angle F, angle C goes with angle G, and angle D goes with angle H. We can do the same thing with the sides. AB goes with EF, you can see the marks. CD is going to go with GH, the CD is over here, GH is over there. And then you can do all the combinations, like you want to do BC, that's going to go with FG. So we're going to end up with the same thing there. That's how we use corresponding sides. Third angle theorem, all this says is if you have 2 triangles with 2 angles congruent, see how angle B is congruent to angle E, and angle A is congruent to angle D, then the third angle must be congruent. You don't actually need to show the third angle. We just know, oh, they must be congruent. And that works because a triangle is 180. If I say this is like 80 and this is 60 and this matches over there, well, if we do the math on it, 180 minus that, we're going to get 40. And we do the math on this one also. Because the triangle, we're going to again get 180 minus 60 minus 8, just like we did over there. We're going to again get 40. So that's why you only need to show 2 sides congruent. Because if you just show 2 sides congruent, and then by math, we know the third side has to be congruent. This concept is going to come up a lot when we start proving that 2 triangles have to be congruent. That concept will come back. And finally, let's do a little check. Do we understand? Name the congruent figures by making the congruent statement. The first figures here are kites. And if I want to say the congruent, it's going to be A, B, C, D. You can start anywhere. We'll say start at A, B, C, D. And that's going to go, since it looks like it got rotated, A would go with E. E, F, G, H. A, B, C, D is congruent to E, F, G, H. Remember, order matters. Onto this one, I have to figure out the ones that match. This first one here, A, B, C, D, it does not look like it matches with that one. It does not look like it matches with that one. It looks like it's this one. It looks like it got rotated this way. All right, we're going to say triangle ABC. And then we want the short side, kind of go with the short side. A and D looks like they go together. It looks like it goes ABC, D, E, F. That's congruent to triangle D, E, F. And then if those are congruent, then these two must be congruent. And same idea. Let's go short side, GHJ. And on here, that would look like this side, KLM. Triangle, it's my bad triangle, GHJ is congruent to triangle KLM. That's the idea.